This video is for learning and conceptual clarity only. Students must not reproduce answers blindly or mention YouTube as the source during practical examinations. Always justify the procedure and results in your own words as per the prescribed syllabus and lab record. The creator, Juanita, is not responsible for any outcomes, results, or actions performed in the laboratory based on this video. Thank you. Okay, so the experiment that we have for today is resistivity of the material of the wire. You have to study the principle of the experiment by heart. The apparatus that we'll be using is a wire of unknown resistance, a voltmeter, a rheostat whose upper and lower terminals are shown, a battery whose positive terminal is in red and the other terminal is in black, a milliammeter. So now this is the circuit diagram for resistivity of the material of the wire. You have voltmeter, resistance, ammeter, your battery. You have to draw a key but you're not using it in the experiment, and you have your rheostat. So in theory, your voltmeter is connected in parallel to your resistance, and then one end of your resistance is connected to the negative of your ammeter, and then the positive of your ammeter is connected to the positive end of the battery. This end that has a longer leg will be the positive end of your battery, and the shorter leg will be the negative end. And then you have your rheostat. This end is the lower terminal, so is this end, and this end will mark the upper terminal. So now you will be measuring the resistance of this particular wire, and that is connected in parallel to your voltmeter. And then the positive of your voltmeter is connected to the negative of your ammeter. So take the positive of your voltmeter connected to the negative of your milliammeter. Okay, and then if you can see in the diagram, the positive of your ammeter is connected to the positive end of your battery. So let's do that. The positive of your milliammeter is connected to the positive end of your battery. It is this end. Once that is done, the negative end of your battery is connected to the lower terminal of your rheostat. Now if you look at the rheostat, this is the lower end, and this is the other lower terminal, and the terminal that is on top will be your upper terminal. Okay, so in your circuit diagram it says the negative of your battery is connected to the lower end of your rheostat. Done. And then if you look at the diagram, it is connected to the negative of your voltmeter, which is this. Tell you how you're supposed to read every single division that is present on the voltmeter. So this is a 0 to 3 volt range voltmeter. Okay, the very first line that you see, the lowest division is 0. Okay, so now this long line is called a major division, and the second long line is called another major division, which is nothing but 0.5 here. So how do you determine the least count of the voltmeter? So as I stated, the major division, second major division is 0.5. Okay, and then your first major division is nothing but 0. So 0.5 minus 0 divided by the total number of lines between 0 and 0.5, which is nothing but 10. So divide this by 10. That will give you the value of one line or one division. So 0.5 by 10 is nothing but 0.05. So each line holds a value of 0.05. So if the first line is 0, the next division will be 0.05. The next division after that would be 0.1. The division after that will be 0.15, and so on and so forth. So the next thing that you have to do is you have to tabulate the values of current in ampere and voltage in volts. How do we do that? So let your first reading be, so right now your voltmeter is at 0. So in order to take it to 0.05, you have to slowly push the slider of your rheostat, and now get your voltmeter to 0.05. Okay, now it's at 0.05, and then as you move the slider, your voltmeter would move to 0.1. Okay, and then what you have to do is write down the voltage as 0.1 volt, and next you need to know what the current is. So check your milliamp meter. It correctly points to 100, but you have to know that we are taking down the readings in milliamp meter, but the tabular column is in ampere, so make the necessary conversion. And your next reading would be 0.2. So when your voltmeter has its needle at 0.2, the reading on your milliamp meter is, right now it is at around 220 milliampere. So my voltage reading was 0.2 and my milliamp meter reading was 220 milliampere. Please don't forget to convert. So now I will just tabulate all the values in a neater fashion. So the first reading was nothing but the current that we got was 100 milliampere. Please don't forget to convert. This can be written as 100 into 10 raised to minus 3 ampere for the voltage 0.1 volts. The next reading was 220 milliampere. That can be converted as 220 into 10 raised to minus 3 ampere for 0.2 volts. Okay, so now please, this is a disclaimer. Okay, please take down the voltage values as you have taken down in the lab. In the lab, you might have taken it as, as 0.05, 0.1, 0.15, 0.2, 0.25, 0.3 volts. In that way, you would have taken it. Since there was a time crunch, I have recorded only 2 sets of readings. Okay, now what is the R value for these? Okay. R is equal to V by I. Our first voltage value was how much? 0.1, and our current was 100 into 10 raised to minus 3. Please substitute those values. Our voltage was 0.1 and our current was 100 into 10 raised to minus 3. What do you get? Take this over to the numerator and then you will get 0.1 into 10 raised to plus 3 divided by 100. Alright, when you shift the decimal to the right, you will be getting another 0 in your denominator. So this will leave you with 1 into 10 raised to 3 divided by 1000. This and this gets cancelled and leaving you with 1 ohm. So your resistance is 1 ohm. This is the first resistance value. Therefore, write it down over here. Your resistance is nothing but 1. Okay, for the next set, note that the voltage is 0.2 and the current in ampere is 220 into 10 raised to minus 3. So go ahead and substitute it. What do you get? R is equal to V by I. What is my V value? 0.2 divided by 220 into 10 raised to minus 3. When you substitute all these values, you will get an answer of 0.9090 ohm. This is just second resistance value. So write it down as 0.9090 ohm. Okay. The next thing that you have to do is you need to add these two resistances and then divide it by 2. Therefore, you will write mean R is equal to 1 plus 0.9090, divide that by 2. You will be getting a value of around 0.9545 ohm. This is your mean R value. Okay. The next thing that you have to calculate is resistivity, which is denoted by the symbol rho. Now this is the formula given for the resistivity of the material of the wire. Again, rho is equal to pi r square into capital R divided by L. Okay, we know that rho is equal to RA by L. Here your A, which is your area, its formula is pi r square. Okay, and as we know, the observation, R value is taken to be 0.355 into 10 raised to minus 3 meters. Okay, and your length value is taken to be 0.49 meters. Since you know these two, substitute them in the main formula. Substitute it in this. What do you get? Rho is equal to again, what is it? Pi r square r by L. Pi is nothing but 3.14. Okay, into what is R? Your mean R. This is nothing but your mean R. It is 0.9545 into, please note, it is the square of your radius of the wire, which is nothing but 0.355 into 10 raised to minus 3 the whole square. Divide that by 0.49. Next, when you multiply these two, you get a value of 2.997 divided by 0.49. Okay, and the square of 0.355 is nothing but 0.126 into 10 raised to minus 3 the whole square. You can multiply this value and this value. You will be getting 10 raised to minus 6. So then you will be left with this. When you multiply it, you will be getting a value of 0.7706 into 10 raised to minus 6. Therefore, your final answer will be rho is equal to 0.77 into 10 raised to minus 6 ohm meter. This will be the resistivity of your wire.